Hello everyone, welcome to class of CA Foundation, Correlation and Regression. So guys, in this class, first I'll talk about what is correlation. We'll discuss different methods of calculation of correlation. Either it is Karl Pearson method or Spearman rank correlation method. Along with these methods, there are other methods which are not that much important, like concurrent deviation method or scatter plot representation. We'll discuss about them in correlation, and then we'll go to the concept of regression, and we'll try to establish the relation between correlation and regression. Okay, so basically, talking about correlation. So correlation, as the word is telling you, it is a relation, correlation. It is a relationship between two independent variables. So if I have two independent variable, let those two independent variable are x and y. Okay, suppose I have two independent variable, and suppose I'm assuming those two independent variables as x and y, and if I want to establish the relationship between those two independent variable, then we'll study the concept of correlation. Okay, so whenever we are talking about correlation, correlation is all about finding the relationship between two independent variable. And when we have a dependent variable where one variable is dependent on the other, and in that form, when we want to establish the relationship, then we use regression. Okay, so there's difference between correlation and regression. Correlation is normally represented with the symbol called R. R is basically the symbol which represent the correlation, and this R is called correlation coefficient. This R is called correlation coefficient. This, the term for this is called correlation coefficient, or coefficient of correlation, or coefficient of correlation. Different textbooks will use different naming, so don't get confused. And the value of this R lies between -1 to +1. Okay, so basically, when we study correlation or when we study regression, they are the part of bivariate data analysis. They are the part of bivariate data analysis. When I say bivariate, bivariate basically means where you are considering two variable. That's why we are calling this as a bivariate. So if I have bivariate or two variable, and I am trying to find the relationship between these two variables, where if both the variables are independent in nature, that the movement of one variable does not affect the movement of another variable, then these variables are said to be called as independent variable. And when the two variables are independent, and imagine if both are going up together or if both are going down together, it means they are positively correlated. It means they are positively correlated. Okay, so the movement of one variable is not affecting the movement of another variable. They are independent variable, and if both are going up or going down together, then it means they are positively correlated. While if one variable is going up, the other variable is going down. Okay, or one variable is going down, the other variable is going up, then they are negatively correlated. Then they are negatively correlated. So the value of negative correlation, it lies from 0 to -1. Okay, and from the value of positive correlation, it lies from 0 to +1. And this R value, the R which represent the correlation between the two value, it lies from -1 to +1. Okay, so if while you are doing some calculation, and suppose if you get the R value which is bigger than 1 and all, it means that you are doing something mistake in your calculation. Okay, so it's the part of bivariate data analysis. I hope you got some kind of idea here, giving you some kind of practical application. You can consider like the movement of gold with respect to the movement on stock market. Okay, as like when you talk about the movement of gold with respect to the movement of the stock market, generally it is believed that whenever the stock market is not performing well, that time gold price will appreciate. Okay, so and when you consider when the stock market is going up, okay, very significantly, you'll not see much movement in the gold price. So that is because they are negatively correlated. Just a simple example to make you understand the what is negative correlation. Talking about positive correlation, maybe you consider all IT stocks and all. Okay, Infosys, TCS. So because they belong to the same sector called IT, so when one is going up, the other one definitely would be going up. If one is falling down, definitely the other one is falling down, because it belong to same sector, they have similar kind of nature of business. So positive correlation, negative correlation, I believe you got an idea about what is positive correlation or what is negative correlation and all. Okay, so going further in this world of correlation, if I have to discuss further on correlation and all, there are different methods are there to calculate the correlation. So first of all, remember correlation coefficient. When I'll talk about correlation coefficient, okay, it values lies between -1 to +1, and the square of this correlation coefficient is called coefficient of determination. The square of correlation coefficient, its square is called coefficient of determination, which we represent with the symbol called rx, r square. Okay, and this values lies between 0 to +1. Okay, this values lies between 0 to +1. Okay, so remember this correlation coefficient, these are the symbol which we represent with r of xy, and then the square of that is called coefficient of determination. I hope this part is clear with all of you. Okay, so here like you can read about correlation and all, and it is used by common man without knowing that he is making the use of the term correlation. For example, when parent advise their child to work hard so that they may get good marks, so they are correlating good marks with the hard work. You can, I hope you are understanding. So when your parents are telling do hard work, and if you do hard work you will get good marks, so it means hard works and good marks are the correlated variable. The study reveals to the statistics of only variables such as height, weight, ages, marks is known as univariate variable. So previously we studied measure of central tendency, we studied measure of dispersions and all. Those are univariate variable. Okay. When in this class, what we are studying bivariate variable. So in the case of bivariate variable, we are talking about the relationship between two variable. Okay, and that is what we study under correlation also, and that is what we'll study under regression also. Okay, so regression I'll discuss later on. Right now I'm focusing on correlation. Okay, so correlation measures the degree or extent to which two variables fluctuate with reference to each other. Okay, this word relationship is important. It indicates that there is some connection between the variable, and it measures the closeness of the relationship. Okay, so if you have the value of correlation coefficient like very close to 1, like 0.78 or zero point 0.8 or zero point 0.9, it means there is very strong relationship. Okay, or minus zero point 0.8 and all, it means very strong relationship. While if you have value very low, 0.00 something, and also that means the two variables are not at all related. Okay, so these are some examples, definitions given by different analyst or stock market or strategist about correlation and all. So you can read this thing, you can pause the video, use of correlation, okay, and then definition of correlation. You can pause the video and go through them. Now, to measure the term correlation graphically, we use scatter diagram. So scatter diagram basically talks about the relationship between two variable in graphical form, and that for that reason only we have the scatter plot. Okay, so imagine if you consider one variable on x-axis and the other variable on y-axis, and then if you use scatter plot to represent their relationship, for giving you an example of scatter plot, maybe this is maybe something like this is x and then this is y. Okay. So just some variable values are there of x 78, 70, 69, 42, and then y there's some value like 90, 94, okay, 82, 87, something like this. Now what I'll do, suppose if I plot a scatter plot, here this is x-axis, here this is y-axis. Now when x is 78, so when x is 78, okay, what is the value of y? So suppose here you have written suppose 50, then 60, then 70, then 80, okay, then 90, here suppose 50, then 60, then 70, then 80, then 90, like this. So when x is suppose when x is 78, what is y? So when x is 78, x 78 is somewhere here, and y is 70, 70 is here. So where you'll find this way, this is the point of intersection. I hope you understood. Then when x is 70, y is 94. So x is 70, y is 94. 94 will be here. Okay. Then when x is 69, 69 means here, y is 42. 42 would be here, somewhere here. So this is here. I hope you are getting. So this kind of relationship, if you are getting, this kind of dotted relationship, if you are getting, and this is called scatter plot representation. And then if you could able to draw a line, if you could able to draw a line by using these dots, by there's a method called method of least square. So we use this method of least square. By using this method, if I try to draw a line, if I try to draw a line, and assuming or by using method of least square method, considering that the maximum points would be closer to the line and all, then automatically there would be strength on the line. And that strength is basically measured by coefficient of determination. Higher the value of coefficient of determination, more stronger is the relationship. Okay, and when you get uh, some kind of this form of visual, then it is means it is a perfectly positively correlated variable. While if you get this kind of representation, a straight line, if you're getting straight line, uh, okay, inclined toward this axis like this form, then it shows a positive correlation, while this form it shows a perfect negative correlation. Okay, so although getting this perfect positive correlation and perfect negative correlation is a difficult task, but if you are getting that, shows the strength of the relationship. Okay, and then you can just pause the video and again read about this theory part, that if the plotted dot lies on a straight line falling from the upper left corner to the lower right corner, there's a perfect negative correlation between the two variable. While if reverse way, if it happen, that shows a perfect positive correlation and all. Okay, so if the point fall in the narrow band from the upper left hand corner to the lower left hand corner, then there's a high degree of negative correlation. This is zero correlation between the two variable. Again, you can just read this theory part. Okay, this you might get a theory question in exam. Okay, one or two question might come. Correlation regression is very important topic. So just pause for the moment and read this concept of merits of correlation, demerits of correlation. Then talking about types of correlation, you have positive and negative correlation. Positive correlation means, I have explained you already, when the two variables are connected to each other positively, means both are going up together or both are going down together, it is a positive correlation. Negative correlation means, when one variable is going up, the other variable is going down. When one variable is going down, the other variable is going up, that is negative correlation. Linear means straight line relationship, if you're getting. Non-linear means zigzag kind, means as such there's no relation you could establish. Okay, it's maybe it's a parabolic relationship, or maybe hyperbolic relationship, then it's a non-linear relationship. Okay, so different types of correlations are there: simple, multiple, partial, total. And you have to read it. Okay, I'll not discuss much theory parts here. You have to read them to have more idea about this. Then this is a important formula for you all. This is the formula of covariance. Okay, this is the formula of covariance. Covariance is again very important uh, variable which we have to study. The formula of covariance between x and y is summation of x minus x bar into y minus y bar by n. This is the formula of covariance as you can see on your screen. Okay, and from covariance actually we can calculate a correlation coefficient. Remember this formula, covariance between the two variable x and y. This is equal to r of xy. R is means correlation coefficient between x and y into standard deviation of x into standard deviation of y. Okay, this is the formula which you have to remember. This relationship, you might get some direct question based on this relationship, that the covariance between the two variable is equal to r of xy. Means correlation coefficient, sigma standard deviation, sigma of x, sigma is the standard deviation. Its formula is summation of x minus x bar whole square by n, or you can write the another formula called summation of x square by n minus x bar ka square. This is the another formula of standard deviation. Similarly, the standard deviation of y, you can use the formula summation of y minus y bar whole square by n, or you can use the formula called summation of y square by n minus y bar ka square. Okay, you can use this formula for standard deviation. For covariance between x and y, you can use a formula called summation of x minus x bar into y minus y bar by n, or you can use the formula of covariance between x and y as summation of xy by n minus x bar y bar. This is the another formula of covariance you can use. So if possible, pause this video and write down these formulas. Okay. So based on this relationship only, we'll find the formula of R. Okay. So we can find the formula of R. So I can write summation of x minus x bar into y minus y bar by n. This is covariance formula. It is equal to r of xy into standard deviation, summation of x minus x bar whole square by n into summation of y minus y bar whole square by n. Okay, so n can be same n1, n2, or they can be different also. Okay, so you can write summation of x minus x bar into y minus y bar by n is equal to r of xy under square root. You can write summation of x minus x bar whole square, then summation of y minus y bar whole square by n square. So you can n into n is n square, and if you bring the n from the square root, it become n, and this n and this n will get cancelled. So you can bring this outside, okay, and this will become n, okay, and then you can cancel this n and this n, okay. So what it will give you? So uh, you can write down the formula of R. Okay. So the formula of R, the R of xy is equal to summation of x minus x bar into y minus y bar divide by under square root summation of x minus x bar whole square into summation of y minus y bar whole square. Okay. So this will give you the formula of R. Okay. R is the correlation coefficient. This is the one formula. The other formula also simultaneously you will get by this relationship. You know that the R of xy is basically covariance between x, y by standard deviation of x into standard deviation of y. So if you use this relationship, you will find the R of xy. So if you divide the covariance between x and y by the standard deviation of x and standard deviation of y, you will get the value of R. Okay. So you can use any formula for that, you will get the answer. I hope this part is clear with all of you. Okay, going further, this is a formula of covariance. Covariance mathematically as such, if you get some value of covariance 0.25 or 0.39 or minus 0.25, mathematically it will not highlight you as such anything, but we use covariance to find the value of correlation coefficient. And one of the method what we use to find correlation coefficient between the two variable, that method is the called as Karl Pearson. Okay, so this is the relationship what I told you, that R means correlation coefficient is nothing but covariance between the two variable divide by standard deviation of x, standard deviation of y. Okay, so basically by using this method we'll find the correlation coefficient between the two variable. So you can remember this. Okay, and this would be helpful for you to find the correlation coefficient between the two variable. Okay, so this is the relationship which I just now calculated for all of you. Summation of xy. Okay, this is nothing but summation of x minus x bar into y minus y bar divide whole divided by under square root summation of x minus x bar whole square summation of y minus y bar whole square. This is the formula of R. Okay, let's give you an example so that you understood. Like here they have given that height of father and son, like x is the height of father and y is the height of son, and they ask us to calculate the correlation coefficient. Okay, so let me write down this. So x and y, so x and y, this is x and then this is y. Okay, so x 64, 65, 64, 65, 66. Height of father 64, 65, 66, then 67, 68, 67, 68, then 69, 70, 69, 70, and then the height of sun is 66, 67, 66, 67, then 65, 68, 65, 68, 70, then 68, 72. So here the height of father and son is given to us. What I can do, I can first find the sum of x. Okay, I can find the sum of y. Okay, sum of x, whatever the x is given, I can find the sum of x. I can find the sum of y. Okay, so sum of x or sum of y I can find. Okay, and for doing this calculation, I need what? I need x minus x bar. I need x minus x bar. So whatever is the x, I need average of that. So I need x minus x bar. I need y minus x bar. I need x minus x bar ka whole square. I need y minus y bar ka whole square. Those data I need. And here no, well, when you calculate correlation and regression, one thing you remember, one thing, 1 minute, when you are calculating correlation and regression, one thing you can remember that they are not affected with the origin or scale. So what I can do, out of these values of x, I can choose any value like maybe 67. Okay, suppose I can choose one variable called 67, and then what I can do, I can subtract all these values of x by 67. Okay, and that I'm writing as capital X. capital X is equal to the small values of X minus 67. Similarly, what I did, all values of Y I subtracted from 68. Okay. So why I'm doing, just to make my calculation simple. Without this also, I can calculate my correlation. Okay. So what I did, I just took one variable out of these values of X, and that variable, let that variable is 67. So what I did, all values of X I subtracted from 67. So I got this value. Then what I did, all values of Y I subtracted from 68. I got this value. Okay. Then what I did, okay, what I did, I just did the square of this. Okay. What I did, I just did the square of this. All these values, what I got, all these values, what I got, these are my capital X. I took the square of this. Okay. So I got this value. Okay, so this is what? This is nothing but sum of x square. Sum of x square is nothing but x minus x bar ka square, and that I'm getting as 28. This sum I'm getting as 28. Okay. Then similarly, what I did, these are the y value I got. So what I did, I took the square of this y and I got the sum as 34. So the sum of y square, or sum of y minus y bar ka square, I got as 34. And then what I did, I multiplied them, and that sum I'm getting as 25. Okay, everyone. So here I got the values of x, I got the value of y, I got the value of x, I got the value of y. If I do this sum, the sum is 469, and here the sum is 476. Here the sum is 476. What I did, I just subtracted all these values of x from 67. Here I subtracted all these values of y from 68. And then what I'm getting sum of x minus x bar. Okay, this will be again 0 only. Sum of y minus y bar. This will be 0 only. Then I did sum of x minus x bar ka square. Okay, this sum I'm getting as 28. Okay, then I did sum of y minus y bar ka square. Okay, and this sum I'm getting as 34. Okay, then I did sum of x minus x bar, sum of x minus x bar into y minus y bar. Okay, and this I'm getting as 25. This I'm getting as 25. Okay, now the same thing what they have done in the textbook, they have written this as x and y. This they have written as sum of y. This they have written as sum of x. Where what they're telling, this x is x minus x bar. And this y is this capital Y. This is y minus y bar. Okay. And this is sum of capital X is x minus x bar. And y is y minus y bar. Okay, and then what the formula I told you, R of xy is equal to summation of x minus x bar into y minus y bar. So what they did in the textbook, they represented this x and y in the small letter. Divide by square root of x minus x bar whole square. Divide by under the square root y minus y bar whole square. So this sum you got as 25, and this 25 you divided with the square root of 28 and 34. 28 and 34, and this has given you the value of r. And if you calculate this r and all, this r you'll get as 0.81. This has given you the value of r, and here you will get the r value as 0.81. Clear, everyone? So in the textbook and all, the same thing you've done in PU, the same thing they've written this as sum of xy divided by square root of sum of x square, sum of y square, where they're calling this as capital X and capital Y, where capital X is nothing but a small x, x minus x bar, and capital Y is nothing but a small y, y minus y bar. Clear everyone? And how this formula came and all, that I have explained you. This is the value formula. Where where this is, this other way of writing, this is summation of x minus x bar into y minus y bar under square root summation of x minus x bar whole square summation of y minus y bar whole square. Clear? So same thing we did with the formula, and then this is another formula for finding the correlation coefficient, and this is another formula. By using this formula also, you can find the correlation coefficient. Okay, so you use this formula, just pause the video. Okay, just pause the video, just see these values, and if you calculate, you will get the R value as 0.95. Okay, the method what I told you, use that method, the formula what I told you, use that formula, and again find the R value. If you do this, if you find the R based on this data, you will get the R value as 0.95. Try calculating the R from this formula. If you calculate from this formula, you will get the R value as 0.95. You can try by yourself. Fine. Similarly, you can try using you again use this data and again calculate the R value. Okay, this time when you calculate, you will get the R value as 0.92. Okay, so this method is called Karl Pearson correlation coefficient method. Use this method to find the R value.